No, actually this weekend, parents are important. Okay, I didn't realize that we had not done number 10. It says solve the equation graphically. So we did do number 10. Yeah, okay. Okay, well, let me go through it with you real quick. I would give you this graph. Absolute value of 4x minus 3. Yeah, I showed you guys this one. But we'll just do this for glory because why not? Absolute value of 4x, we'll do it for the glory, minus 3. And then the other equation is 5 times root x plus 3. X plus 4, thank you. And so what I would do is I would just cut and paste this graph onto the test. And then you need to find what the x-coordinate of those two points of intersection are. Yeah. Okay. Came to you in a dream? You can. Okay, so if you want to do it without graphing, you have to look at this and realize that absolute value is two separate equations for a straight line. This one is 4x minus 3. This one is negative 4x plus 3. So the way you would solve this without graphing is you would go, let's let 4x minus 3 equal 5 times the square root of x plus 4. And then let's also let negative 4x plus 3 equal 5 times the square root of x plus 4. Okay? And solving those two equations is a joy. Do you want to keep going? I will cut and paste the graph onto the test, and you just have to estimate the x values of the points of intersection. That's all you do. So Ben, if I was to solve this now algebraically, I'd have to square both sides to get rid of the square root. So that would be 16x squared minus 24x plus 9 equals 25 times x plus 4. Where did I get? Multiply those two together, and then you write. So that would be 16x squared minus 24x plus 9 equals 25x plus 100. And then 16x squared minus 49x minus 91 equals 0. And then I'd have to quadratic formula it from there. And that would give me this answer right here, because I did that with the positive absolute value. Uh-huh. Okay. Did you get this answer? Oh, okay. Did you get this one? But you don't remember what you did? Huh. No. Yeah. Yeah. I don't know. I don't know. Okay. Number 11. Solve the equation by completing the square. So, what number do I have to add to the left side of that equation to make it a perfect square trinomial? In other words, to make it into something that I can factor, bless you, as the same thing squared. You're on the right track. What I'm going to do is I'm going to add 4 right there, because if I do that, that makes that factor into x minus 2 times x minus 2. Okay? We'll talk, don't worry. If I add 4 to the left-hand side, then I have to add 4 to the right-hand side to make it balance. And so now I've changed this into x minus 2 squared equals 11, okay? Where the 4 came from, so that you don't freak out too much, is I took this number right here, I cut it in half, and squared it, okay? So if, for example, I had started with x squared minus 8x equals 7, what number would I add here to make this a perfect square? 4 squared, which is 16, so I'd add a 16 there, and I'd add a 16 there. This then factors into what? X minus 4, because negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So this would factor into x minus 4 squared equals 23. Shelby? Okay, the reason why this is a handy problem-solving method is because now, how do I solve this for x? Square root both sides. So the square root of this is x minus 2. The square root of 11 is plus or minus the square root of 11. And then how do I get the negative 2 over there? Yep, add 2 to both sides. So 2 plus or minus square root of 11. Okay? Yes. So Carly says, why are we not doing this just the regular old-fashioned way and just going x squared minus 4x minus 7 equals 0? Because there are no two numbers that multiply together to be 7 and add to be negative 4. So this does not factor. Okay? However, hang on just a second. If you did this, you could use the quadratic formula instead and get to the same answer. Okay? Okay, that's fine. This is just a little bit faster of a method. Okay? Whatever method you use is up to you as long as you get the right answer. I don't care. Yes? Okay, did you get 2 plus or minus square root of 11? Okay, winner. All right, next one. Solve the inequality absolute value of x minus 8 is greater than 4. So this sort of relates to what Ben and I were talking about. When you have absolute value, you have to use two equations because the absolute value is a V-shaped graph. So you have to have one equation for each side of the V. So one of the equations is x minus 8 is greater than 4. And in this case, the other equation is x minus 8 is less than negative 4. So the first thing that I did is I just wrote it regular, right? The next thing that I did is I switched the inequality and I switched the sign of the thing. And then from there it's pretty easy. How do you solve x minus 8 is greater than 4? You add 8 to both sides, so we know that x has to be greater than 12. I also add 8 over to here, so that means x is less than 4. So using interval notation for this, like it wants us to, x is less than 4 means that x could be from negative infinity to 4, and x is greater than 12 means x could be from 12 to infinity. That's why we're reviewing it. Well, I mean, I don't know what else to tell you. Yeah. It's not surprising that you don't remember it because it's not something that we use very much. So you learned it, and then we didn't use it again, and then your brain flushed it. Right. Okay, next one. Let f of x equal the square root of x minus 3 and g of x equal x squared plus 1. Compute g of f and state its domain in interval notation. So g of f means take the f function and plug it into the g function. Okay? So I'm going to take this entire thing and substitute it in there for the x. So instead of saying x squared, I'm going to say the square root of x minus 3 squared. Then, yes, Ben noticed that the square root and the square will cancel. So that's x minus 3 plus 1, which is x minus 2. Okay? Then we need to say what the domain is. So the domain of this is going to be the domain of the function that you're plugging in. So what's the domain of the square root of x minus 3? What's the smallest number that I can plug into there? 3. And then if I go lower than 3, nice job, Emma. If I go lower than 3, then I'll get a negative number underneath the square root, and you can't take the square root of a negative number. So the domain is from 3 to infinity. Great question, Glory. Thank you for asking that. One of them is a bracket because you can plug 3 in, but you can't plug infinity in because you can never get to infinity. Oh, wait. This is honors pre-calculus. Yes. No, I'm just kidding. You're probably fine. It's not about colleges. It's about learning, Emma. It's about being the best version of yourself. It's about trying your hardest at everything that you do. Shelby? Like not square brackets? Yeah, because this does not say equal to, so that means it gets a round bracket. Yeah, if either one of these said equal to, then they would turn into a square root. Also an excellent question. All right, let's play again. Let's do another one. Graph the relation defined by the parametric equations when t goes from -2 to 3. So t is going from -2 to 3. So these are my t values. So I'm going to take those and I'm going to first plug them in to figure out what x is. What does x equal when t is -2? Okay, what does x equal when t is -1? Do you see where she's getting these? She's just taking this number right here and plugging it in for t. So -2 squared is 4. 4 minus 5 is -1. Okay? -1 squared is 1. 1 minus 5 is -4. So, Emma Bobemma, what do you get when you plug in 0? Okay? What do you get when you plug in 1? What do you get when you plug in 2? Negative what? Nope. If I plug in 2, 2 squared is 4. 4 minus 5 is -1. And what do you get when you plug in 3? Plain old 4. 3 squared is 9. 9 minus 5 is 4. Okay, now we're going to do the same thing, but we're going to plug them into the y equation. So what do you get when you plug -2 in for t into the y equation? -3. Then what? Then okay. Everybody see where we got those numbers? Ben, you're not here today, just in case you're curious. You have a Ben Wills, other Ben has a pre-excused absence. Were you supposed to go on that field trip? Probably. Okay. Nice job. All right, so now we're going to use those numbers to make ourselves a graph. So, -1, -3. -1, -3 is right there. -4, -2, 1, 2, 3, 4, 1, 2. -5, -1. -4, 0. I see you uttered. -1, 1. And 1, 2, 3, 4, 2. like that. A little sideways parabola. Okay? All right, next one. The following three transformations are applied in the given order to the graph of y equals x squared. First thing, a vertical stretch by a factor of 3. How do you take x squared and stretch it by a factor of 3? Nope, you put a 3 in front, you multiply it by 3. If you added 3, what would you do to the graph? If you go x squared plus 3 on the end, yeah, then that would move the graph up 3. Okay, then the next thing it says is a horizontal shift to the right 5 units. So when we're moving things to the right or to the left, we have to do it inside parentheses, and it's the opposite. So if I want to move it to the right 5, instead of going plus 5, I'm going to go minus 5. And then finally it says a vertical shift down 6 units. So I'm going to take this whole stinking thing and subtract 6. So that matches with answer choice B. So you're saying we could have been done that right at that point? Okay. Note to self, don't make this problem a multiple choice on the test. All right, number 16, let f of x equal 3x plus 7 over x minus 2. Find a rule for f to the negative 1, which is the inverse of f of x. Anybody remember how we did these? Anyone? No? Okay, the way we did these is we switched the x and the y, and then we solved for y. Inverse means flip those around. Yeah, what's up? Yeah, you can. Why were you running through the town yesterday, Will? Yeah. You went running down that street over there, carrying some books in your hand. Oh, good job. All right, how do I solve this for y? Multiply both sides by y minus 2. So on the left, what do we get? Yeah, but I want to just get rid of the parentheses. So I get xy minus 2x. And then on the right, what do we have? Yes. 3y plus 7, because these two things cancel. Nope, I'm just trying to cancel it. You're thinking of the conjugate. That's when you got like square roots involved in there. But now I'm just trying to get it to cancel. I'm basically just cross multiplying. You could think of this as being x over 1, and then I'm just cross multiplying them together. All right, this last step is a little bit tricky. I'm trying to solve this for y, but there's two different terms with y's in them, and they're not like terms, so I can't combine them. So what I'm going to do is I'm going to get everybody with a y in it on the left, and everybody without a y in it onto the right. So I'm going to rewrite this as xy minus 3y equals 2x plus 7. So I subtracted the 3y over to the left, and I added the 2x over to the right. Okay, the reason why that helps me is because now that I have the y terms both on the same side, I can factor out that y. So y equals parentheses x minus 3, or y times x minus 3 equals 2x plus 7. And then how do I get rid of the x minus 3? Plus. Divide both sides. No, not plus, because it's multiplying the y. So those cancel. So y equals 2x plus 7 divided by x minus 3. Shelby does. Therefore it happened. Grace? Never mind. Okay. Yeah, that's kind of a weird way to say that, huh? It just, yeah, that's the answer. That means like a function rule. All right, number 17. Find an equation for the parabola having vertex 2, -5, and passing through 4, 7, but express your answer in standard form. Anybody remember vertex form of a parabola? Anybody have it in their notes? The vertex form of a parabola is y equals a times x minus h squared plus k. We could very much have a parabola poster where it says the vertex is negative b over 2a. That's the, yeah, vertex form, standard form. But make a rough draft on paper first, and I'll tell you if that's what we need or not. I'm just going to go with yes. I don't really know what we just said, but okay. Okay, so now we are going to just plug in a bunch of numbers. Okay, where does the 2 go? Nice. 2 is the x-coordinate of the vertex, so it goes in for the h. 2 is the x-coordinate of the vertex, so it goes in for the h. Where does the -5 go? In for the k. Where does the 4 go? That's an x. What does the fox say? Where does the y go? That goes in there for the y, and then what we're trying to do is take this and solve it for a. So, okay, so plus 5, so 12 equals a times 4 minus 2 squared. Yep, do inside parentheses first. Order of operations, please excuse my dear Aunt Sally. So 12 equals a times 2 squared. Okay, solve the puzzle though. Good, a equals 3. What will we do with this 4 right here? We've simplified 4 minus 2 is 2. We just did inside the parentheses. Nice job. You have won a 1-week vacation to Cabo and a free motorboat. All right, so now we know that y equals 3 times x minus 2 squared minus 5 is the vertex form of the parabola. But they would like for us to write it in standard form. So that means I'm going to FOIL out the x minus 2 first. So I'm going to rewrite that as x minus 2 times x minus 2 instead of x minus 2 squared. Jordan, what's going on there? Nothing? Are you like picking strings off your pants or texting someone? Oh. So what'd you say, Emma? So now I have to FOIL the x minus 2. You guys know what we get when we FOIL that? Can we do that in one step? X squared minus 4x plus 4 minus 5. You guys can check our work if you want, but that's first, outside, inside, last, and then we combine the like terms. What do I do next? I don't plug in 3. Distribute the 3. And then my last step is to combine like terms. And we got her. Okay, number 18. Which of the following could represent a complete graph of f of x equals ax minus x cubed? Why is a no good? Because it's a parabola. Why is d no good? Because that is not what x cubed looks like. This thing is crossing the x-axis 1, 2, 3, 4, 5 times, so that means it's an x to the 5th. So this one is also out, okay? So we just need to know whether it's B or C. Which one do you think? It is actually B because the higher exponent is negative, and so that means the graph is going down. So you see how as I go from left to right here, this graph is falling generally overall. This would be the answer if it was plus x cubed, because that graph is going up. Highest exponent is negative, means graph is going down. Okay, number 19, find a degree 3 polynomial with lead coefficient of 4 and zeros, -2, 1, and 5. Easiest problem ever. Are you ready? Don't blink or you might miss it. Here's the answer. Y equals 4 times x plus 2 times x minus 1 times x minus 5. I'd do a pen drop, but then I'd have to bend over and pick up the pen. I don't want to deal with that. Doesn't have quite the same effect, Evan, I don't know. Everybody see how that happened? That's it. Nope. If it said find a degree 3 polynomial with leading coefficient 4 and zeros, -2, 1, and 5 in standard form, then we'd have to FOIL all that garbage out. I'm sorry, I didn't hear you. I thought you said that you hate math, and I know that can't be. No, you would never say that. All right, let's do one more, and then we'll knock off the rest of them. No, my legs are really tired though today, but I have been on a crazy exercise kick, like 12 days in a row, some sort of physical activity. I'm a stupid man. I need a day off, but I know I'm not going to exercise when I'm in Minnesota. So, okay, so you guys remember synthetic division? What goes in the box? -2, and then what goes here? 1x to the 4th, -3x cubed, -4x squared, 8x minus 2. Good. Bring down the first number, and then it's just repeated multiplying and adding and 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 multiplying and adding. -2 times 1 is -2. Add those together, you get -5. -2 times -5 is 10. Add those together and you get 6. -2 times 6 is -12. Add those together and you get -4. -2 times -4 is 8. Add those together and you get 6. Okay? This is not actually what this problem is asking us to do, but works for me if it works for you. Yeah. There's I don't even know. Okay? So if you wanted to, what we just did is we took this thing right here and we essentially divided it by x plus 2, and we got as an answer x cubed minus 5x squared plus 6x minus 4 with the remainder of 6. That's what just happened. Okay? Yeah. Okay. pick the rest of it up, like I said, tomorrow. And